Welcome to another episode on my Arduino Mega2560 and connected to Arduino Uno using serial peripheral interface over these wires. Fischertechnik mechatronics with switches for signaling and fischertechnik motors with propellers. Now, recently I've been very focused on SPI, which does work in a way, and surprisingly things, well, not quite surprisingly, things tend to go not always as expected. First thing that happened was that these probes from the oscilloscope, well, of course they just pick signal, but those signals are well, not quite according to what happens in the code, and that is surprising. So when I show the oscilloscope, it looks like all being very quiet, apart from an occasional peak, as you can see there, but no signal low or signal high. The yellow one is for the clock, the blue one is for data, the purple one is for device select, and the fourth one is for master input slave output, or vice versa. Anyway, they are not as expected. Back here, what I want to do again is see how the SPI gets to work, and then also try to get this motor back to working, because yeah, and this should work better. Let me try to put that connection more firmly into it, but since that is not for the motor, it has no use. Then well, whatever comes to mind, and that may be anything varying from switches to electronics. And last time the time before that I adjusted this transistor and got a motor back to work. And at times they do, and at times they don't. Anyway, it's a lot of wires coming from the history of setting up my Mega2560, and this still needs improvement, but this only has use when I get this right. And then when this is right, then it's time to get this straight again, because the intention is still that this one triggers a signal with the switch, so the SPI backward signal is given, if possible. Anyway, that is ongoing stuff. For now, back to the code, where things did not exactly work out last time. It goes better, but still quite a few questions, such as what is actually sent from the Uno to the Mega2560. Is it character, is it byte, and if so, whatever it is, how is it sent? Because the values still don't match. After showing the real circuit, this is the wiring at the Uno side again. Yellow, dark blue, almost black, light blue and purple. Clock signal, master input, slave output. Data, master output, slave input. And as is not, which is always inverted. And even that is strange right now, simply because it is not even inverted right now. So where does it come from? Where does it go? Is it even connected? Right now I don't know. Anyway, back to this. So this has some stuff. Maybe the time base is set too quick, I don't know. Let me put it to a very different value, like half a second. But then again, I should have an inverted signal, which is currently SDA. So this should indicate that I switched blue and purple. Really? Then also this is odd. Right, let's just see if things work the way they should. Uno, and the port is Uno. Then monitor. Well, despite whatever is shown on the oscilloscope, this is very correct. Spi Test is coming, 0 is coming through, and this is what I did last time. I ended with this. So all things considered, this is working. SPDR new is, what was that again? Right here. So this is SPDI test. SPI test is coming in here. No doubt about that. So the question is still, why is this going wrong? If C is 0, which it is, because it is printed SPDR in 0. Here, SPDR in 0 is 48, which is also, oh, by the way, so that is the very last character coming in. Or is it? I think so, yes, that was it. That was ASCII. ASCII character for 48 is 0. So that was completely correct. So it's sending ASCII, the ASCII characters, bytes. If character is 0. But then I say, alright, it is 2. And then it still says it is 30, which it is very much not. So what happens if I say 0? If I put 0 back, let's see. No, capital S, 38. 83 is the that should be the capital S. What is being done then? I would like to know. So let's first see whatever this gives. Why would that be 48? If C is 0, then I can also say, alright, I am not assigning anything else to SPDR. So then it would be 38. Last known value. I'm not getting it. 48 is 0, so that would be 0 on this side as well. Let's see if that works out. Serial monitor on the 2560 side. From SPI it says 10, it should be 0. "48" is a 0. If I check on here, SPI test, that's a 0. This is a 0. And 0 and 48 are the same. So if I don't change anything, it remains 48. SPDR remains 48. And I should get back 0. So what goes wrong? It generates a signal, but apparently you can't do anything back, although the example that I showed before says different. So what's the culprit? And yes, pondering about it for a long time. I've tested anything and just about everything. What I can do maybe is put exactly the same thing here. Maybe that's where I go wrong. So instead of SPDR is S or 1 or 0 or whatever, I would say constant character pointer P is, let's just make it 0. and then say C is pointer P, and that should be about it, or anything. Now it should be alright. Well, not quite, because let's say this goes here, and then say SPDR is C, and then something should happen. It happens here, so why not here? Alright, then I would have to interrupt this one, select board, select port, upload, compile and upload. Done. So what does serial monitor show? I'm very curious now. It's still the same. 0 is 48, but here it says 0. It's SPDR1 is 30. And in this line nowhere is 30 to be seen. Alright, this is hexadecimal. It is hexadecimal. So let's say I quit using this and no hexadecimal anymore. I just want to see what it is. SPDR1 is what? SPDR is 48. Is that correct? No. 48 is 0. Yeah, well, it is 0. Is 48 is 0. Alright, then I change it, and I wanted to have what is an I? The third is I is 73. I is 73. If it moves now, if it changes now to 73, I may have found the problem. But unfortunately, the first result is negative. 48. 48. So that was, even this is not a solution. Where does it get its value from, is what I wonder. Let's step away from SPI for now and look at electronics. One of the things that is quite typical is that there are several transistor circuits on the board. This is one which drives this motor, the second one which drives this motor, and this is supposed to run, and it does run, slows down, but this one is driving this motor which just keeps running. Then this one drives this motor, keeps just running. Well, condition is of course that the wires are fixed, so I better put this one further in, which is, by the way, a wire to the switch, not to the motor. And then this one, which stopped running unexpectedly for some time ago. And the question is, why did it stop running? Well, if I take this wire and put it in the red line, it will start running again. But then again, that is not the whole point, or not the point I want to make. This is the SPI LED. This is the LED of this transistor, like this one and this one. So what will happen? Well, let's just take this out and put it just, well, let's say right here. This is red as well, power. And it should start running right now. That's odd. It does not run. That's very curious. It doesn't run at all. So, question, is the motor broken? Well, I don't expect it is. This wire is too thick. I really need to replace these wires. But question is, why doesn't this motor run? Do I have enough wires to replace these? I don't know. I already replaced once these wires with these, and then this motor started to run. So nothing happened electrically, or nothing changed really. So I have three questions then. Why doesn't this run? Well, this is this one is controlled by the Uno. That is clear. And it is controlled by pin 7. A very quick look at 7. Yes, it is the motor. And where does it come from? Where does it go to? And to my surprise, as far as I can see, nowhere. So that's not good. Neither is this. It does run, but not always. This hardly ever runs while everything is working. So let's get back to the code again. To the Uno, but then output 7. So last part for this episode, concentrating on what we just saw, analog out pin 7 for the motor. In the video segment I couldn't really locate it. It would be very odd if it is not even set, because then it would make very much sense that it doesn't work. and even in this completely grayed out part I don't see it. So analog out pin 7, where are you? Then it should be somewhere here. Out pin 7 here. Yes, of course it does work. Of course it does work, because the LED, this LED is working, so it does work. And another point is that I found out that the values of the other motors are different, which are, let's take a look at that again. Where are those pins? For NTC is not it. For LED, for lamp. And that is a very good question. That signal is going to 7 right here. If I look correctly. No, it's not. Yes, it is 7. So this line goes to the motor next to the motor that is not doing anything. This motor. I put 7. So in a quick glance, let's have a look at its value, and I have the feeling that I did that in the past, not too distant past, and found out that the value of 180 is in fact a correct value. So this is all set. Serial monitor. And then output analog out pin 7 I should take a look at. Output value 1. Output value 1, which is 253. Yeah, so if that is the value that I have to use, 253, then I put it now to 253, and hopefully it will work again, but I have serious doubts. Uno, and once again do Uno, upload. Will it work? Will it start working? Not quite. Not at all. Unfortunately. So I have to really pay more attention to that. SPI, well, that's a no-go for now. Still don't know why things go the way they go. Still have to re-find out how these pins are, how these signals relate, because this I can just ignore, and it worked so beautifully at the start. Anyway, enough questions and riddles left. if you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment. Follow me via Twitter, retweet and like. Follow me via Instagram and like. Leave a comment, whatever. Please donate to keep videos coming to you. More information at the start of this video. My website is under this video. Please take a look there. Also more information on donating. And this is going to be continued with SPI, with electronics, with code, you name it. For now, bye bye.